So we're going to add on to our notes. Yesterday, was it yesterday? No, Tuesday. All right, on Tuesday we were doing some factoring. Looks like this. All right, so this is what we left off on. And we're going to be doing the same general concept today. Some of it's going to be a little bit more extended, and some of it's going to be with different types of zeros. So all of these zeros from last time, when you have like integer values or fractions, those are called rational zeros. All right, it's something that can be written as a fraction. So today we're going to be doing some of those. We're going to mix those in, but we're going to also be doing real zeros. And so what a real zero is that means you're allowed to have integers, you're allowed to have fractions, but now you can also have radicals. All right. So integers, fractions, and again, radical zeros. All right. Now, when I'm talking about the radicals, I'm not talking about negatives under the radicals. All right, these are just like positive roots. So we are going to have to use the quadratic formula, which is why we spent a whole lot of time doing it. All right. So let me show you one of our examples. And so the function, we have f of x. We have 8x to the fourth minus 14x cubed minus a 71x squared minus 10x plus 24. And now, since you have a fourth degree polynomial, I have to give you two factors instead of one. So we're going to be given that one of the factors is x plus 2. And another one of the factors is x minus 4. So very similar to what we did last time, where you had a third degree polynomial. And when I give you one of the zeros, what you have left is a second degree that can be factored. Well, now if I only gave you one of the zeros, now you'd have a third degree and you wouldn't really know where to go from there. So you have to have two separate factors that you're going to use. And we're going to use them separately. So what we're going to do is we're still going to do our synthetic division. Bless you. We're still going to use our synthetic division. But if I take x plus 2 and set that equal to 0, I'll have one of my zeros to be negative 2. And the other one is going to be a positive 4. And so I need to use this factoring polynomial techniques that we were doing to find the other two zeros and find the other two factors. So we're going to use one of the zeros and do synthetic division. All right, it doesn't matter which one you pick. All right, since they're both factors, it doesn't matter whichever one you start with, you just have to use the other one for the second step. So just pick one. All right, so first I'm just going to use, I'm going to use the 4 because it's positive. All right. So I'm going to use that one first. And your polynomial is already in descending order with no gaps. So I don't have to have any placeholders. But you may want a calculator. So I'm going to get my calculator. So I'm going to drop the 8 down. All right. So 4 times 8 is 32. And so that I don't make any kind of mistakes, I'm going to do my negative 14 plus 32 so I can make sure I drop down the correct value. Because with such large numbers, I do not want to screw this up. Because if I screw it up, then I got to start all over. So now I got to do 4 times 18, which 18 is already on my screen, which is nice. So I can just multiply that times 4. And I get 72. And this one's a little bit easier. I don't really need my calculator for that one. When I add those two together, I just get 1. So I don't think I need my calculator for the rest of it. So 4 times 1 is 4. And then when I add vertically, I get negative 6. And 4 times negative 6 is negative 24. which is a good thing. If I didn't get that 0 as a remainder, then somewhere I would have done something wrong in terms of my synthetic division. Because if I'm telling you it's a factor, it has to work. There's no other options. So with what we have at this first top piece, this is a 4th degree polynomial. So this one down here is our 3rd degree. I'm not going to do anything with it right now. I'm not going to rewrite it. I'm not going to do anything different. All I'm going to do is I'm going to now use my other 0. This -2. I'm going to use that 0 on the outside again. And I'm just going to continue another synthetic division box. All right, so I have to do synthetic division twice. And so to chunk my work and try to keep it nice and tight, I'm just going to write the other 0 on the outside and now start doing all of my drop downs. Ladies, stop talking. It's getting really old. So when I drop my 8 down, right now I'm using this as my 3rd degree. Right? So everything we do now is with a -2. So -2 times 8 is a -16. And then you're going to add vertically. -2 times 2 is a -4. And again, make sure that you are adding and subtracting correctly. That's why you have your calculator if you need it. But again, I need to make sure I get a 0 remainder for the second factor also. Because if I don't, I'm in big trouble. And so now what I have is if this was a 4th degree, then after the first synthetic division, I had a 3rd degree. And now this is a 2nd degree. Once you get down to a 2nd degree polynomial, now you can solve this by either factoring using some sort of area box, or you can use the quadratic formula. It doesn't really matter which one you pick. Sometimes you'll be forced to use the quadratic formula just because it's not factorable. Right? I'm going to check to see if it's factorable. Right? So second, I'm going to try and factor. Right? But again, if the factoring doesn't work, or if I just like the quadratic formula all the time, you can always use the quadratic formula. And again, you're using this like bottom polynomial right here to figure out what are you going to put in your boxes or your ABC, whichever you choose. So we spent like 6 or 7 days on factoring or using the quadratic formula, and this is why. So if I am going to try my area box, and I put 8x squared in the top, a minus 3 in the bottom, I'm looking for a product of negative 24x squared that adds up to be a 2x. And so 6 and 4 work, but I need to put the positive value on the 6. Since they're opposite signs, the larger factor has to be the positive one. And then I can factor outwards. So 4x, which leaves a 2x minus 1 at the top. And then at the bottom, I can take out a positive 3. And so this factors to a 4x plus 3 and a 2x minus 1. Those are my other two factors. So they gave me 2 at the very top, or I gave you the first 2. And because it's a 4th degree, same thing as on Tuesday, whatever the degree is the number of factors and the number of zeros you have to find. So I had 2, right? I found the other 2. And so right now, my polynomial, if I were to factor this completely, would automatically get the first 2 that I started with. But now I have to attach the other 2 that I just found. And so that's the factored completely polynomial. But you also have to identify your zeros. And I started my list up here. And so I still have to set these 2 factors I just found equal to 0 and solve. So I still have to figure out when this value is going to be a 0 and this value. And you can do that mentally if you need to. but I don't want you to make a mistake. All right. So I need one of my zeros to be negative 3/4, and I'll put that in my list. And then it looks like the other 0 is going to be 1/2. So this is what you're going to be having to do right now when you have a 4th degree. So on all of your 4th degrees, unless you are factoring a common factor out first, you are going to have 2 of the zeros, and you're going to have to do a double synthetic division.